Welcome to my Module 3 presentation on multiple regression. So when we're talking about multiple regression and correlation MRC, we want to assess the relationship between a predicted and predictor variables. You can have multiple predictor variables, and this is where the GLM, which is the general linear model, comes into play, as it allows you to fit in as many predictors as you want, but you must be careful in selecting predictors that you think would be applicable. So this makes the multiple regression, very flexible. And so in the last line, you can see the equation line, which is basically y is our predicted or response variable, and that is equal to our b naught, which our b naught represents our intercept, plus the b, which would be our slope, multiplied by our x, which would be our predictors, plus e. E in the case of multiple regression stands for error. In ANOVA, it would stand for, no, my bad. E in regression stands for residuals, while E in ANOVA stands for error. And Cortina talks about it's important to remember that multiple regression only handles continuous dependent variables. You cannot have dichotomous variables, which would be better handled in ANOVA. So given the data, what we're trying to do is look at, does theory of mind, executive function, and IQ predict camouflaging in children with autism? So to your right, you can see just the basic descriptors I ran on my data, and we had 30 participants. So our dependent variable here is camouflaging, while our predictive variables are theory of mind, which we refer to as TOM from now on, executive function, EF, and IQ. So you can see we fitted our model, and I just want to note that this is the data is continuous. So let's dive into how, let's assess how these different predictors impact our response. So in MRC, there are numerous assumptions we would have to check for, and based on if these assumptions are violated or not, we would then do diagnostics to see like what particular outliers or what are the issues that we are having. So first, we're checking the assumption of normal distribution of error or our residuals. Are these residuals normally distributed? And based on this histogram, you can see that it is definitely skewed to the right. Usually normal distribution, you would have that bell shape, and as you can see here, it does not taper off to the ends. There seems to be a gap, and this definitely does not look as though it is normally distributed. So let's see, let's check out other assumptions and then see how we're going to tackle this issue. So we plotted our residuals, and what we're checking for here is homoscedasticity, which is that we want our residuals to be a constant around our best fit line, and we don't want it to violate this assumption. So this is the second assumption. If it does, it is considered heteroscedasticity, and this is an issue. But looking at this, you can notice a few outliers. It looks pretty, I would say the distribution does not look that concerning, but I want to investigate some of these outliers a little bit more. So I generated a QQ plot to see like who are these outliers, and it identified 14 and 27 as my outliers. Now when you are looking at making predictions, you have the options of removing or keeping your outliers in and moving forward, but the QQ plot basically is showing me, well, these are my concerning participants, and you would have to make a judgment on whether or not you keep them or you remove them. But let's check the other assumptions first before we decide on what we're going to do. So before we get into multi-collinearity, I just wanted to check the correlation between predictors. Between the predictors and the response variable. So looking at this correlation matrix, you can see that Y3, which is theory of mind, is highly correlated with Y1 being our camouflaging, which is our predicted variable. So it's pretty much, looks like there isn't much high correlation between, for example, Y2 and Y3, and then Y3 and Y4, and Y2 and Y4. So that's pretty good. So I don't think multi-collinearity can be an issue here, but let's investigate further. So when we talk about multicollinearity, it basically is when they have two or more predictors that are highly correlated, and what it's doing is you can't independently tell which one is predicting for your response variable. So the issue with that is that when it comes to hypothesis testing, it poses a more of a problem versus if you were just like trying to make predictions. So at the bottom of the screen you can see the VIF value, which is one of the tests, and the closer it is to 1, it means that there is lower correlation or no correlation, whereas if it goes closer to 5, then there is some correlation issues. But based on our correlation matrix, you can see that we don't have that issue. And if you look at Y3, Y3 seems to be significantly a significant predictor based on the 0.001 level. So what does this mean is that basically for every unit increase of Y3, which is theory of mind, there is a 0.01 increase in camouflaging. And now we're looking at our multiple R squared value, which is 0.06. It's also known as your coefficient of determination. And King talks about this being the distribution of the spread of the points around a regression line. So around the regression line. And that is specific to that sample. Now, King talks about this being an issue because sometimes people take this for generalizability. But you need to just keep in mind that this is specific to your sample. Our R squared is also the square root of, multiple R squared is the square root of R squared. So basically, our data indicates, for example, for theory of mind, not theory of mind, for the model, that around 0.063 will be approximately 63% of our variance in camouflaging can be explained by the predictors in our model. And this is just a plotting of our predictors against the response variable. So this is executive functioning, theory of mind, and IQ plotted against camouflaging. And you can see that it's, for example, Y3, which we talked about being theory of mind, which is our second image, that there's almost that perfect linear relationship. You can see it's really, all of them are actually relatively going in a positive direction, but you can see, like, for example, executive functioning, the points are more scattered. So these are some factors that we have to consider, the assumptions we have to consider when we are fitting our model. Based on this, we violated basically the normal distribution of errors. So we may have to go back to the drawing board. There may be some issues within our data. We talked about the outliers, so maybe we have to go back and check to see how it's going to fit if we remove our outliers. Also, our sample size is pretty small. So these are some factors you have to consider when you're going to use a model. But we can't say surely that, theory of mind is a predictor of camouflaging. So if you're going to test this, we can say safely so far that theory of mind is a predictor. A good predictor, that is. So as we move into ANOVA, I just wanted to highlight the main differences between this and MRC. So E stands for error in ANOVA, whereas the E is considered residuals. Multiple regression and correlations handle continuous variables, whereas ANOVAs, they are listed as factors. Now, ANOVA and MRC both use the GLM model, but it's more of ANOVA's test for association, while MRC considers differences. So now we're moving into ANOVA, and what we were testing is that we were looking at theory of mind and executive functioning on camouflaging. So our hypothesis looks at, does theory of mind have an effect on camouflaging, and does executive functioning have an effect on camouflaging? And we also want to look at the interaction of theory of mind and executive functioning on camouflaging. So the table on your left, you can see we did a table of our distribution of participants. So for EF stands for executive functioning and TOM theory of mind. So EF, they had 2 levels, 0, 1, indicating that they did not have it, 1 indicated that they did. Theory of mind, similarly, 0 meaning that they did not, 1 meaning that they did. And from looking at that diagram, you can already see we already have unequal distribution of our participants, and this already impacts statistical power. So keep that in mind going forward. Looking at our image on the right, which is a Levene's test, we tested for the assumption of equal variance, and since the p-value is greater than the 0.05 significant level that we're using, we can assume our assumption has been met because it is not significant. So that means that the variance isn't that off, so we can say that we met that assumption. They have another assumption called the independence of observations, but you can't really test for that. So noted, we used a randomized design. So looking at our summary information, you can see that we across the factors, you can see TOM and EF do not have any significant effects on camouflaging. Similarly, the interaction between theory of mind and executive functioning, there isn't any significant effects, significant interactions that are going on there. The box plot on the right also shows you that you can see that the median values are all around the same for the different groups. So for the first one is for theory of mind and those who do not have it, comparing it to the second one, which is those who do have theory of mind. You can see that the median value is quite around the same, even though the distribution is slightly different. In those without theory of mind, the distribution is negatively skewed, whereas in those who do have theory of mind, the distribution is more positively skewed by the upper quartile of the box plot, showing that there's more data concentrated there. So these values that we got could be attributable to the fact that we had unequal participants, distribution of participants to begin with. So maybe we need to look at our sample sizes. Also, we can continue this analysis by going into looking at the outliers and to see if they kind of skewed our data. But as you can see, there have not been any significant effects nor interactions. And these are just some hand calculations that show the MRC and ANOVA. So this is the end of my presentation. Thank you.